Hello Algebra 2, and here is a solution video for 9.1 through 3 review worksheet. So we're going to start off with your special triangles. What I always like to recommend is inside the border of the sides of your special triangles, I like to put the ratios that go with each side. So opposite the 30 is usually a 1, which I'm going to give times x, whatever that is. Opposite the 60 is square root of 3 times whatever your x is. And opposite the 90 is 2x. I guess, to be perfectly honest, usually I would write this as x root 3. Same thing. Okay, so once we have those established, let's go over here and see what we have. So I'm going to label up the triangle with a color and then get rid of it when I do the next problem. So A, we want to find A, so this is what we're looking for, and we are given that B is 6 rad 2. So that means 6 rad 2 represents our x. And what we're looking for is x times rad 3. So that means I'm going to multiply both sides of this equation by rad 3. So x rad 3, which represents side A, is actually 6, whoops, this was a rad 2, sorry about that, 6 rad 2 times rad 3, which is 6 rad 6. That is what A would equal. All right, then we go on to the next one where we want to find B, so this is what we're looking for, given that A is 8 rad 3. Well, that makes things a little bit easier, because if the side that has an x rad 3 is 8 rad 3, when you compare those two, I could divide both sides by rad 3. That tells us that x, which is our B value, is 8. So we know that B is going to be 8. All right, now this last one, oops, I just erased my this is x rad 3. My daughter's watching Family Guy downstairs, so you might hear that a little bit in the background. Sorry about that. So C is on the 2x side, that's our hypotenuse, and A here is 24. So these are the harder ones. So we know that x rad 3, that's the ratio that goes on that side, equals 24. So first thing we're going to do is solve for x, and then we can double our answer. So that means I divide both sides by rad 3, which we know you're not allowed to have a radical in the denominator. So I'm going to multiply top and bottom by rad 3. The bottom becomes 3, the top becomes 24 rad 3. Well, 3 goes into 24 8 times. So x, I'm going to kind of continue it over here. We have that x is 8 rad 3, but we want 2x. So that means that 2x is 16 rad 3. You don't do anything to the radical, you only multiply the coefficient in front. So C is going to be 16 rad 3. So that's how I would do the 30, 60, 90. Then we move on to the 45, 45. So those ratios are usually x, because it's 45, 45. Those two sides are the same. This is x rad 2. So the first problem is going to ask us to find C, the hypotenuse, if A is 4 rad 2. So A is on the side that says, so we know that x is 4 rad 2, and we are looking for C, which is x rad 2. So I'm going to multiply both sides by rad 2. That means that x rad 2 equals 4 rad 2 times rad 2, which is 8. So C is going to equal 8. Then our next one, find B if C is 16. So if C is 16, Well, that's kind of like number 3. So we set 16 equal to the ratio on that side, which is x rad 2. We're trying to solve for x, so we divide both sides by rad 2 so that we isolate x. And from there, we notice, because you can't have a radical in the denominator, so we rationalize. That is going to give us 16 rad 2 over 2, and we can then simplify that. So that's 8 rad 2. B is going to equal 8 rad 2. All right, so that's our special triangles. Now we're going to be converting degrees to radians, radians to degrees. Remember, you're always using either pi over 180 or 180 over pi as your conversion factor. So if it comes to you, I'm going to make this a little bigger, if it comes to you with a pi in it, and we want that pi to cancel, so I'm going to multiply by 180 over pi. So pi's will cancel, and now it's just reducing. So 10 will cancel this 0. 3 times 18 is 54. So that reduces to 54 degrees. The next one, since it's in degrees, we want degrees to cancel. So we're going to multiply by pi over 180. So these degrees symbols are going to go away. And then we can just reduce. You can use your calculator or work it out. 34 over 18. 2 goes into both of those, so 2 goes into that 17 times, negative 17, this becomes a 9. So your answer is negative 17 pi over 9. This third one, we have a pi, so we're going to multiply by 180 over pi, so that my pi's cancel. Then 9 will go into 180 20 times, 4 times 20. Is 80 degrees. And I think I lost one of my problems, so let's shift this over. 210, we want degrees to cancel, so we multiply by pi over 180 degrees. So the degrees will cancel, and then we want to reduce. So let's see, 3 goes into, the zeros will cancel. 3 goes into 18 6 times. It goes into 21 7 times. This mess becomes 7 pi over 6. Okay. Now, this next 2 problems, finding another coterminal angle is just a matter of adding and subtracting 360 degrees. That's really all it boils down to. So 210 plus 360, that is going to give you a lovely 570 degrees. 210 minus 360 is going to give you a lovely 150 degrees. So those are kind of friendly. Even if it's a negative, so negative 450, notice if I add 360, I still get a negative value. Well, that's okay, so I'm going to put that down as our negative version. I'm going to take that negative 80 and add another 360, so that now I have a positive 270 degrees. So if you have a really large negative or a really large positive, you might have to go around the circle more than once to get that positive or negative version. Okay, so now we're into, we have a right triangle. Theta is an acute angle. Again, that means less than 90. So I'm going to put theta right here. We have a little clue. Sine theta is 1/3. So remember, sine is opposite over hypotenuse, which makes that the adjacent. Make a little right angle there. So I know that the opposite is 1. The hypotenuse is 3. To figure out my adjacent, I'm going to do some Pythagorean theorem. So I know that a squared plus 1 squared equals 3 squared. So a squared is going to equal 9 minus 1. A is going to be the square root of 8. So that's 4 times 2, which becomes 2 rad 2. So this side will have a 2 rad 2 on it. And now we can write our ratios. So the sine of theta is, like they said, 1/3. The reciprocal of that, 3 over 1, or 3. I didn't have to write over 1. Cosine is the adjacent over the hypotenuse, so that's going to be 2 rad 2 over the hypotenuse, which is 3. When you reverse that, you're going to get, I'm going to do it down here, you're going to get 3 over 2 rad 2. We cannot have that radical, so we multiply top and bottom. So that gives me a 3 rad 2 on top. On the bottom, I've got 2 times 2, which becomes 4. Tangent, sorry, is opposite over adjacent, so 1 over 2 rad 2, and again we have to rationalize that. Rad 2 over rad 2, so we're going to have a rad 2 on top and again a 4 on the bottom. Cotangent is adjacent over opposite, so that's just a straight 2 rad 2. And then moving on down to the bottom of the page, -6, -8. So when you create a triangle from a coordinate, you want it to look like one of our bow tie triangles. So I'm going to go -6, -8. That's our path, -6, -8. The hypotenuse always comes out of the origin, so this is the theta prime really that we're working with. It's actually your reference angle. We need to do Pythagorean theorem to find our hypotenuse. So 6 squared plus 8 squared equals 100, and the hypotenuse is going to be the square root of that, so that's going to be 10. So if I wanted sine, once I have that now, theta, that means this is the opposite. That's the adjacent, that's the hypotenuse. Sine is going to be opposite over hypotenuse, -8 over 10, which you should reduce, so that's going to be a -4/5. Secant is the reciprocal of cosine, so instead of adjacent over hypotenuse, it's hypotenuse over the adjacent, and we can reduce that to 5 over -3. Tangent is the opposite over the adjacent, -8 over -6, so the negatives make everything positive, and this reduces to 4/3. Now for our next point, 4, -2, so I'm going to go out 4, down 2, and then this comes out of the origin. There's my theta, so this is your opposite, your adjacent, your hypotenuse. And we do a Pythagorean, 4 squared plus 2 squared, that's 16 plus 4 is 20. 20 is 4 times 5, so that's going to be 2 rad 5 when we simplify that. Here we go. All right, so then to do cosine, cosine is the adjacent over the hypotenuse, so we have 4 over 2 rad 5. Well, right off the bat, those two become 2, but I do have to rationalize the rad 5. So I get 2 rad 5 over 5. Cosecant theta is the reciprocal of sine, so that's the hypotenuse over the opposite, 2 rad 5 over 4, and I can reduce that to rad 5 over 2. And then lastly, cotangent is the reciprocal of tangent, so it's going to be adjacent over the opposite, and that simplifies to rad 2. -2. Okay, so now we're going to sketch the angle in standard position and find its reference angle. Remember that a reference angle is always acute, means less than 90. It's always going to be positive. It's the distance to the closest x-axis. So 220 degrees. Here's our initial side, always on the positive. Remember, this is 180. So 220 is going to be somewhere around here. Again, we are just estimating. So that is my angle. The reference angle is right here. I'm going to put a little theta prime right there. So the difference, because this is ending at 220 degrees, so theta reference, or theta prime, whatever you want to call it, is 220 minus 180. It is this distance right here. to the nearest x-axis, and that is going to be 40 degrees. So now we come over to when it is in radians. So to actually do 4 pi over 3, I tend to like to do it in degrees. That's more natural. Pi, remember, equals 180. So 180 divided by 3 is 60. 60 times 4 is 240 degrees. It's kind of like the problem we just did. So I'm going to come around. 240 will be a little bit further. So that would be 240 degrees. And your reference angle is going to be right in here. So it's this distance to the nearest x-axis. But if you, oh, I'm sorry, that's equivalent to 4 pi over 3. Now the easiest way to find that difference in radian mode is you just pick off this little part. You don't multiply it by, I always do the pi divided by whatever's in the denominator. That's going to give you an acute angle. So your reference angle is just pi over 3, which is 60 degrees, 180 divided by 3. Number 17, we have negative 320. So we have to do our angle in the reverse. So we go clockwise now. Negative 320 is just less than 360 by 40 degrees. So here is that angle, and the reference angle is right here. So if this was negative 320, to get all the way back to negative 360, that means my reference angle was 40 degrees. Okay, hope that worked okay. Now, this is the only problem where you're going to need a calculator. So we are given side, 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 and we're going to do some law of cosines and some law of sines on this triangle. So this side is 6, b is 10. Remember, the lowercase is opposite the capital letter. And you always, 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 there are reasons for it that we're not going into because it's just hard to do big explanations through a video, but always solve for the largest angle first. The largest angle is always opposite the longest side. So we want to solve for C. That means this side, this is your side angle side for law of cosines. So we're going to go 12 squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of our unknown C. So remember, the bookends are the angle and the side opposite that angle. So we're going to move things over slowly. We have 12 squared. We're going to subtract 6 squared, which will take that away, and then subtract 10 squared, which takes that away. Now this is all combined against cosine with multiplication, so we divide by negative 2 times 6 times 10. That will equal the cosine of C. So what I'm going to do here is I'm going to turn that fraction into a decimal. So you're going to have 144 minus 36 minus 10 squared, which is going to become 8 over 60 times 2, negative 120. Remember, to solve for an unknown angle, you have to do the inverse cosine of that degree. And make sure you're in degree mode. This in turn is going to give you 93.82. So we're going to round up. Angle C is 94 degrees. Okay, so now that gave us our first angle. Now the second angle, I'm going to write it up here, 94 degrees. The second angle, I can use law of sines because I now have a pairing of a side and an opposite angle. And since I'm looking for an angle, I'm going to put my angle on top. So the sine of 94 is to 12. As the sine of, doesn't really matter which one you do, I'm going to do B, is to 10. That means I can multiply both sides by 10 so that those cancel. And when you do 10 sine 94 Oh, I did it differently on the answer key, so I have to actually work this out. 10 sine 94, close parenthesis, divided by 12, gives me 0.83. So I have to do second sine. So we're going to do an inverse sine of that decimal, which is 0.83. I tend to just use second answer when I'm doing these. Gives me 56. So angle B is 56. And that third angle, you never have to do any trig. You can just subtract from 180. 180 minus 56 minus 94 is going to give us A. So 180 minus 56 minus 94. Ooh, 30 degrees. There we go. Okay. Now, notice down here, here's a filled out unit circle. So at this stage, we just want you to know how to use your unit circle, okay? It is really helpful moving on, if you take another math course, to know how to use your unit circle. So to remind you of a few things, we had established so the unit circle has a radius of 1. That means the opposite represents a y value, the adjacent represents an x value. So we had that the sine of theta is always going to be the y value, cosine is always going to be the x value, tangent, which is opposite over adjacent, is going to be a ratio of those, and then you're going to have your reciprocals. This will be 1 over y, secant theta will be 1 over x, and cotangent is going to be x over y. So you'll make a ratio of those coordinates. So we start with, we have cosine 120 degrees. So we find 120. We find the x value. That is going to be a negative 1/2. Then we go to secant, 5 pi over 3. 5 pi over 3 is right here. Remember, secant is going to be the reciprocal of the x value. That's going to be the reciprocal of 1/2, which is 2. Then we move on to tangent of 240. So 240 is right here. And so we want to make a ratio of the y value. So tangent 240, I want to show you something. This is rad 3 over 2, that's the y value, divided by a negative 1/2. If you invert and multiply, so that becomes negative 2 over 1. Notice that your denominators are always going to cancel. So when you're making that ratio, just ignore the denominators that divide. Notice how everything is divided by 2. So you can just ignore that and just look at a ratio of the numerators. So I don't want to lose my negative. This is going to be a negative rad 3. Cotangent, 7 pi over 4. So let's find 7 pi over 4. When we look at this, is right next door. Cotangent is the x value over the y value, but in this case they're both rad 2 over 2, rad 2 over 2, one's positive, one's negative. So rad 2 over a negative rad 2 is just a negative 1. Then we move on to sine 5 pi over 6. 5 pi over 6 is right here. Sine is the y value, so that's going to be a positive 1/2. Then we have our quadrantal angles. The quadrantal angles are these. They are the angles that the coordinate hits the x and y axis, and you can still make a ratio. Cosecant is the reciprocal of the sine, which is your y value. So at 0 degrees, sine of 0 is 0 over 1, which means cosecant then is going to be 1 over 0. You may never, ever, ever divide by 0, so this one is undefined. And I don't know if this helps you to remember this. I learned this on Pinterest. No, because you cannot divide by 0, versus okay. It's okay to have a 0 on top because that would equal 0. All right, I hope that helps.